All right, folks. Good afternoon. Thank you so much for joining us today, the week before our holidays. Really appreciate you being with us. My name is Yuri Grinstein. With me is Priyanka. Please introduce yourself.
Yes, I am Priyanka Vergadia. I work with Yuri, and we are going to host Mabl today.
Yeah, excellent. Thanks for being here with us. And we are incredibly excited today because for the first time on GCP Live, we have an actual GCP customer here with us today. We have James and Izzy from Mabl. Guys, I would love for y'all to introduce yourselves.
Sure. Thanks a lot, Yuri. I'm Izzy Azari, one of the co-founders of Mabl, which is an automated testing service. Formerly used to work at Google after my first company, Stackdriver, was acquired by Google back in 2012 or 2014. Sorry.
I'm James Baldassari. I'm a software engineer at Mabl, and I'm just going to go through some of the process we went through earlier this year when we had to come up with some of our high-level architecture and decide where we're going to build Mabl, which cloud services are important to us, and how we came to decide to use GCP.
Awesome. And again, thank you so much for being here. We really appreciate it. It's always fantastic to have the customer perspective. Priyanka, this topic is actually really personally interesting to me. First, because my career began in software automation.
That's awesome.
When I was in college, I interned with a company that built test automation tools, and that was my first job after college, doing tech support for them. And now Stackdriver is like my main area of expertise within GCP.
That's awesome.
So hey, by the way, thanks for building Stackdriver. I think it's a really great product. Yeah, so
it's actually also interesting to me because my first job was also a software automation engineer. Right out of school, I was automating for an IVR company. The use cases for chatbots and phone systems. So it's also very interesting to me. So I'm very excited to be a part of this today.
Awesome, guys. So you've at least got two people here that are really excited to hear what you've got to say. So again, thanks for being here. So tell us about Mabl. Tell us kind of what y'all do and how you do it.
You want to? Sorry, sure. Yeah. So actually, if you want to go to the slides real quick, first one is just a high-level overview of what we do. We're a software test automation company. We were founded earlier this year. Our initial focus is for test automation with web UIs. And the idea is to kind of make it easier to create and maintain tests and find bugs quickly. And another main value prop of Mabl is that we use machine learning to find a lot of issues that maybe might not be as obvious. And even if you're creating your own manual test, you might not find on your own. So that's kind of the high-level overview.
Awesome. I mean, sounds like a lot better than what you and I used to do back in. Well, we wanted to name the year in the interest of not dating ourselves. That sounds really powerful. All right, tell us how it works.
Yeah, I think I'm going to hand it over to Izzy, and he's going to give a quick demo so you can kind of see for yourselves.
That would be perfect.
Great. So hopefully you can see my screen. So I was going to give a quick couple-minute demo of Mabl. So first of all, Mabl is a SaaS application, and it is running all on GCP. Basically, what a customer does is uses Mabl to point at their web application, and then Mabl does testing based on that app. So as an example, I will create a new application, and for this purpose, I'm just going to point it at Spotify for now, since most people are probably familiar with that company.
It's a good choice of application, given that it's actually another GCP customer.
Got it. Yeah. And I'll just call it the Spotify marketing site. If I had a login for Spotify, I can actually add credentials, and Mabl would actually automatically find the login box on that page and automatically log in. But for now, I'm just going to test the marketing website itself.
Yep. So that looks incredibly cool, just the fact that you can literally point it to the homepage and it goes from there.
That's great.
With a background in test automation, I have a million questions about like how the authentication actually works and how it tests dynamic transactions and a million other things that I honestly don't think we have time for today, but it looks like it worked. So what happens now?
So now what Mabl's doing is it's running two different default tests. So the first test is just loading the Spotify homepage and making sure that loads, and it does that over time, and it keeps a track of how long those tests take. So if I looked at the output, it would show me that this test passed. It took 11 seconds. We take screenshots of all the pages we go to, and you can see that finished the test execution successfully. If Mabl had caught any problems, you can filter and see if there's any JavaScript errors or if there's any broken links. But in this case, the page loaded just fine. The second thing that Mabl is doing now is it's kicking off what we call the link crawler. And so what this is doing is it's going through every single page off of that Spotify.com domain and making sure that all those pages load. It's taking screenshots and checking to see if there's any links that are broken or any JavaScript errors. And these two tests are just default tests that run in the background to make sure all apps are always working. And you can see so far it's checked one page, 14 links, no failed links, and no JavaScript errors yet. The third thing you can do is basically create your own tests for Mabl to run. And so as an example, I will go to tests and I'll create a new journey. And a journey is basically a customer journey you'd want to test within your application. And so I'll test Spotify marketing site again. And I'll just say I'm going to click around a little bit. And it's just pre-populating those fields for me. And now what we do is we've developed what we call Mabl Trainer, which is basically a Chrome plugin, which records all the different things that you're doing within your application. But the really interesting thing about the trainer is it's not actually recording all the XPaths and elements. It's actually recording lots of different elements about, or lots of different data about the areas you're clicking, and uses that to actually do the testing. So as an example, I'll scroll through the app, and let's say I'll go to Premium. You can see it's following what I do. Let's say I'll go to check out the terms that apply. You can see the terms. Let's say I wanted to make an assertion in my application that the logo for Spotify is present, so I can apply that assertion. And let's say I wanted to go to the end and make sure I can get to the help link.
Very cool. So, I really like that it converts the assertions and the steps to natural language. That makes it much easier for someone coming in after the fact to understand what this is supposed to be doing.
Yeah, that's exactly right. We want it to be easily usable by lots of different people. And so I'll save that journey now. So it brings me back into the Mabl application right now. And you can see here's all the different steps that my journey took. I'll now name this journey the same thing. And you can see all the other fields are populated. I can put a description in here if I wanted to. And then basically you can run these tests on an ongoing basis. I'll say every 3 hours. Or you can run it on a deployment. So if you wanted to run it every time you checked in code into your CI system, you can do that as well. And then you just click. And now this test will run in addition to all the other tests that we have running. And so this is the way Mabl basically tests an application, both from a default perspective and for user-required tests.
Very cool. I mean, that looks really powerful, and I have to say, really easy to use.
Yeah.
Thank you.
Much better than what we were doing.
Yeah, exactly. All right. So awesome. Thank you for that. So now that our audience has some context as to what Mabl is and kind of what it does, obviously what we would love to understand next is how do you use GCP to accomplish this?
Sure, definitely. I'd love to explain that. You could bring me back over the slides real quick. I'll go through some information for you. Hopefully, as Izzy was giving this demo, you may have had in your mind some idea of the types of cloud services tool. To give you a very high-level overview of the architecture, this is vastly simplified, but going from the left to the right of the screen, we have a modern single-page application-based UI. This is a React application, but it could have been any similar application that's basically static assets that are hosted, and most of the rendering is done on the client side. So it could have been Angular or Vue or any of those other frameworks. But the key there is we just needed the ability to host these UI assets somewhere. The UI communicates to the backend through the RESTful web interface. Component of the architecture has to be fast and horizontally scalable. We have to store those entities that the UI is interacting with, like the test that Izzy was creating, applications, environment definitions, all those things in an entity database of some sort. Then what we need to do is execute these tests. So we have to have a scalable cluster where we can kick off tests that will hit the various pages that you've defined and generate output. And there are a couple different types of output that Mabl deals with. One is sort of large-ish files, like you can think of things like screenshots and log files and things like that. Those go into a pretty traditional like file persistence layer. You can think of something like cloud storage or S3. And then the other type of output is more of a streaming real-time metadata. And so as the test is executing, we're generating information about broken links and tests passing or failing and how long each thing took to run, things like that. And those get streamed into an analysis system, and that's also where we apply machine learning models to it. And the outputs of that process go into an analytics database where we can either do manual queries on them later, or we can do big queries and build machine learning models from that data set, things like that. So that's basically it at a very high level. So we started coming up with like, what do we want this thing to look like at an architecture level? And then how do we map this architecture onto cloud services? And that's kind of, at that point, we started comparing various cloud providers, and we kind of pretty quickly limited our comparison down to GCP and AWS based on the services that we thought we would need and what each of the various cloud providers could give us. Mm-hmm. So this is kind of a high-level overview of those services that we were comparing on the two platforms. So file storage, like I mentioned, this is things like screenshots and log files and stuff like that. You know, for us, when we were looking at AWS and GCP, there's probably not a huge difference there other than maybe price, but the features and functionality of those of S3 and cloud storage are pretty similar, so that wasn't a huge differentiating factor for us. Mm-hmm. Yeah, the next one, yep. Then we looked at pub/sub messaging. So just let me go back briefly to this architecture diagram. A lot of these arrows here are connected via pub/sub style messaging. This allows us to have a decoupled architecture where the clients don't really need to know where the servers are, and gives us a lot of flexibility about who can listen to events, things like that. So that was pretty important to us. We looked at Kinesis and pub/sub here. In terms of the feature set, they're pretty similar. There's one slight difference in the way that that subscriptions are handled, like new subscriptions versus existing subscriptions. Whereas you know, AWS, when you create a new subscription, you can actually look in the past on that stream, versus pub/sub, you can only see new things coming in, right? For us, that wasn't a major limiting factor because most of our subscriptions and publishers and topics are long-lived. So we're not constantly creating these things and tearing them down.
How much value did you like being able to have a global service for like your messaging bus? I'm assuming that you're not running this in multiple regions around the world, but I'd love to know kind of what your take is on the ability to like publish and subscribe from anywhere in the world, whether that made any difference.
Yeah, we're starting small and simple, but the idea is, you know, eventually we want to be as close to our customers as possible, at least where the tests are executing. So we're definitely going to go multi-region in the future, and so that may be more of a factor as we grow. Yeah,
well, I think, not that we should be putting the cart before the horse, but I'd love to have you all back on in a few months when you figure out your multi-regional architecture, so we can.
Exactly, that's going to be that project. Yeah, but the one thing that we really liked about pub/sub over Kinesis was how easy it is to use and scale. So in my past role, I was a heavy Kinesis user. We had hundreds of shards, and we're pushing over 100 terabytes of data through it a day. And it was great until you found out that you needed to scale it up or down or do anything to it, basically. Yeah. And at that point, it becomes pretty painful where you've got to start splitting shards or merging shards. And it's definitely easier now than it used to be, but it's compared to PubSub, it's like PubSub is dead simple. It's just, you just call it as often as you need to, and that's it. And you don't have to worry about scaling or anything like that.
Yeah, and I think you hit on something really important there, which is this idea of having to manage the underlying infrastructure under what is ostensibly a managed service can certainly be, it's a real double-edged sword, right? On the one hand, it gives you more control because you can like manage your capacity and manage performance more precisely. But on the other hand, it's another thing for you to have to worry about.
Right. Yeah.
Yeah, not only that, but it's also, with Kinesis, you're pre-allocating your capacity. So if suddenly your usage drops, well, if you don't scale down, you're still paying for resources that you're not using. So it's, there are a lot of reasons why PubSub, but we found was a lot easier to use and manage.
Yeah. All right. Cool. All right. Well, we could be here talking about PubSub for hours. So
yeah,
I want to make sure you guys actually get through your whole list. I apologize for interruptions.
Then on the NoSQL database, we knew we would need some kind of NoSQL database to store a lot of our entities. Again, DynamoDB and Datastore are pretty similar on the feature set. Similar to Kinesis and PubSub, though, what really separated this was there's no management overhead for Datastore. You just use it as much as you need to, and it automatically scales up and down. Versus DynamoDB, where you're pre-allocating read and write throughput.
Yeah, that sounds like a pretty different approach in terms of like how much management you'd have to do.
Yeah, I think that's one of the common themes here.
Yeah, I'm starting to detect the theme kind of as you go down the list here.
So we also needed the ability to have auto-scaling HTTP endpoints. So for this, we were looking at Beanstalk and App Engine. I think these are pretty similar in terms of their feature sets as well. Let's see, then moving on to container services. On the AWS side, there's ECS. Now, this is an area that's changed a lot. Keep in mind, when we were doing this comparison, it was Q1 of 2017, and it's amazing how fast cloud moves. So some of this has changed. Now AWS actually has a Kubernetes hosted offering. They didn't at the time. But one thing we liked about the Google the cloud option was that it was hosted Kubernetes, basically. It's pretty much vanilla Kubernetes. So if we felt the need to move off of Google for whatever reason, we felt like it would be pretty easy to deploy that anywhere else, really, versus ECS, which is a little bit more tied to AWS in terms of the container orchestration.
Awesome. Yeah, and that makes a lot of sense. One of the things I'd love to understand more, and I don't know how much time you want to spend on this, but I'd love to understand how you use App Engine versus Kubernetes Engine. Like, in your opinion or in your experience, where have you seen App Engine make more sense versus where have you seen like running your own containers on Kubernetes make more sense?
Yeah, so for App Engine, we're using that to host all of our backend APIs, our RESTful web services. I think that it makes a lot of sense if you've got a situation like that where you're just using basically like a Java web service, or you just have a simple server that needs to scale dynamically, but you don't really need a whole lot of control over it. I think that works pretty well. In Container Engine, that's where we're running all of our tests. So these things are firing up instances of Chrome and Java containers and hitting websites and things like that. And in that case, they're more like one-off jobs that need to spin up very quickly and then shut down. So we found that was a pretty good use case for Kubernetes Engine.
Okay, very cool.
Next thing on the list is UI asset hosting. And for this, the requirements were pretty simple. We basically just needed a static file host. But what we found with Google Cloud is that Firebase is a pretty powerful option. It also includes the real-time database, which allows us, and other features that allow us to actually dynamically push content into the browser much more easily than we would otherwise. So I think the more we use Firebase, the more we're thinking like this is a really cool tool that we're glad we have.
Yeah, and I think it's definitely an underrated piece of technology. And like sort of in the blatant sales pitch, it's also free. So it's like a really powerful set of functionality that is obviously back-ended by GCP, but you're not actually charged for using Firebase at all.
Yeah, and the new functions feature is also added into Firebase. So all of those things together make a really good package.
Yeah, I was just watching one of the other online GCP meetups that was talking about some of the recent Firebase features, and I was like, wow, this is really cool. I need to try it out as soon as I have some free time.
Oh, wow. So are you actually saying that we are here to influence people's decisions? You have that kind of power.
Yeah.
That's
cool.
awesome. I'm really happy to hear that. All right, so now I think it like how you compared services and the components you compared certainly makes sense.
Yep, I've got a few more that I can run through just real briefly.
Please continue.
Yep, so for ETL and analytics, we were looking at Elastic MapReduce on Spark and AWS, and Dataflow and Dataproc in GCP. We didn't really know anything about Dataflow or Apache Beam, which it's sort of based on. But the more we learned about it, the more we were kind of intrigued. And
let me actually ask you a question about that, because this is a topic that has come up in lots of conversations for me, is when people are, they're sort of very familiar with Spark. Priyanka, I don't know if this is your experience as well. Like, they're familiar with Spark. They've started to work with Spark streaming. And I think people are generally happy with that. I think obviously there's a lot of advantages with Beam.
Yeah.
I would love to get your take on kind of what that process was on, going from like Spark to Beam. Was that hard? Did you see, like, were there things that you just couldn't do? Were there things that you gained that you weren't expecting?
Yeah, I think one of the common features when we're comparing these two platforms is, we know we can build it in either place. That's not really a question. It's just, can we get a slight edge in either platform that would be a competitive advantage that would allow us to build the service quicker or have less management overhead, these types of things. And I think Beam is one of those areas where we saw a slight advantage for a couple of reasons. One is that, again, it doesn't really, by using the Beam interfaces, we don't really lock ourselves into GCP. We could run them on Flink or even on top of Spark in some cases. So this is something that's portable that we can run other places if we need to. And the other thing is that Beam's got a really nice unification of the streaming and batch processing APIs. Whereas in Spark, you've got the traditional like batch API and then Spark streaming. So you kind of have to decide ahead of time, which one of these do I want to build on, and it's not quite as easy. With Beam, you just change your data source from like a file to a pub subtopic and you've got streaming. So that's pretty powerful.
Yep.
All right, good deal. Let's keep going.
Okay, yeah. So let's see, analytics database, Redshift versus BigQuery. I think this is another area where these are pretty similar, and we didn't really see anything in either direction that was really swaying us significantly. Lambda versus Cloud Functions on the serverless side. This was kind of a nice to have for us, like the ability to respond to various events in the system, whether it be a message on a pub subtopic or a file being dropped into our persistence service. That's just really kind of a convenience factor for us that we saw would be useful in a few different places.
So let me ask you a question about this one that also kind of ties into the data flow conversation as well. I mean, it's like well known that Cloud Functions supports, way fewer languages than Lambda. Obviously, if you're going to be going with Beam, your options are, Java and Python, and really only Java if you want to do streaming. How much did like limitation of available languages affect your decisions, or did you just figure, we can either learn the languages or staff up as needed?
Yeah, I think it's definitely good that it started with JavaScript because that's, we're using JavaScript in our UI as well, and so there's some overlap there. It would be nice to have other languages as options, but I guess So in this area, just in general, we saw AWS's offering as better in this case. Yeah, so they have more languages available. It's been around for longer. It's more mature. Cloud Functions, I think, right now is still in beta officially. So yeah, there are a lot of things that were kind of in AWS's favor on this one.
Sure, that makes sense.
But it wasn't a deal breaker for us. It was just another check mark in the AWS column.
Fair enough. All right, keep going.
Okay, so machine learning. We looked at a couple different services here. This is another area where I think 2017 has seen significant changes, especially on the AWS side. But early on, when we were looking at this, comparing the AWS machine learning service to ML Engine, ML Engine is definitely more flexible because AWS machine learning is mainly targeted at logistic regression models. And we knew that we would need different types of models other than that.
Yep.
Like Bayes, for example, Bayesian models.
Mm-hmm.
So for us, that was a real limiting factor on the AWS side, and GCP was more flexible. So that was a big advantage on GCP. And ML is critical for what we're trying to do here.
We have a question that popped up in the chat. How did pricing compare between AWS versus GCP, and was that really a consideration or not in your decision making?
Yeah, this is actually a very hard thing to compare, pricing, because the pricing model is different on a lot of these services. Like I mentioned, for example, Kinesis versus PubSub. With Kinesis, you're pre-allocating capacity, and with PubSub, you're paying for what you use. So it's pretty difficult to compare those. A lot of it depends on how sophisticated your scaling is and things like that. So it's difficult, but so I wouldn't say it was like our number one priority. What I will say is that both platforms, GCP and AWS, have generous startup incentives. So we took advantage of those. I think they're pretty comparable in both platforms.
Yeah, I'd say the biggest thing for us was more product focused, product feature, and making sure we can build on the platform that helps us accelerate our product roadmap as quickly as possible, as opposed to where we're going to optimize from a pricing perspective.
Very cool. And I know that you're now about to get into monitoring and tooling. So obviously, as experts in Stackdriver, I imagine we had a bit of an advantage in this department.
Yeah, you can say that. I think everybody here is a big fan of Stackdriver, so that was an easy decision for us in that column.
Yeah, it seems a little unfair, but I'll accept it.
I will say, to Amazon's credit, CloudWatch is a lot better than it was in the past.
Yeah.
But Stackdriver is a great tool, and we've come to rely on it pretty heavily. And then in the last column here, tooling, this is another category where AWS has a pretty big advantage, I think. CloudFormation is a really powerful tool. It plugs in with a lot of third-party tools like Ansible and Terraform and other things.
Yeah.
On the Google side, there's Deployment Manager, but it doesn't quite integrate with every service as far as I know.
No, I think this is something we've heard elsewhere. There's a reason that we actually did a dedicated Terraform session on this meetup. I think maybe about a month ago when Antonio was on to talk about Terraform. Is that we do have a lot of customers that do end up looking for solutions to either complement or replace Deployment Manager because of some of the limitations that we've seen there. And obviously, CloudFormation has a multi-year head start there, so it makes a lot of sense that they would have more advanced and more mature capabilities in that area.
Yep. So right now we're using gcloud command line to do most of our deployments and environment creations and things like that. And we're looking forward to seeing where Deployment Manager or maybe some similar service goes in the future. We're looking forward to seeing some improvements there.
Well, watch this space. I think we're going to have some interesting announcements in the next couple months.
Cool. All right. Looking forward to it. So I guess just to sum up all the services that we compared and everything we looked at, we took probably 4 to 6 weeks. It was a pretty significant amount of time that we spent trying to make this decision and learning more about GCP because a lot of us weren't familiar with it at the time. Oops, what am I doing there? So the decision basically came down to a few different factors for us. The first was the hands-off managed services. We really felt that a lot of these services like PubSub, Datastore, Dataflow would take some of the burden off us of managing them, so we can just focus more on software development than keeping services running. So that was a big one for us. The second one was portability versus vendor lock-in. Every cloud platform is going to have some degree of cloud lock-in, and I think we expect that. That's the trade-off you make. But it seemed like Google was making an effort at least to use more open source frameworks that were easily portable. So if we got started with GCP and found out that, you know, within a month's time or so, this wasn't going to work for us, we wouldn't have wasted all that work. We could take what we've done and move it somewhere else if we absolutely need to.
There is a question that popped up here in the chat. Sounds like you use command line tools, so G-Cloud SDK, but they're interested in knowing what language wrapping you used.
Okay, so for our initial, the initial creation of our projects, we did a lot manually and just kind of recording the steps that we executed with G-Cloud, so that we could reproduce them later. And then, other than that, we're integrating. We use CodeShip for our builds, and so we have some scripts that we call after the build completes to perform the deployments. So that's pretty much it. It's just basically simple scripts.
Well, hopefully that answers, Michael, your question on the chat.
Let me know if there are any follows.
Yeah.
And then I guess the last deciding factor for us was machine learning. Google's machine learning services seem to be much more flexible and powerful than one we could get through the AWS managed services. And again, I'm sure we could build something flexible and powerful on our own, but the whole point is to kind of save us time by using these managed services. So whatever we can take off the shelf that's going to work for us is a big advantage.
It's funny that like I think the three things that you just described, you know, ease of manageability with managed services, machine learning, are like those are the things that I think we try to stress when we talk to customers that are considering GCP. So it's great to hear that like what you saw is pretty much what we think our advantages are. So thanks for validating. Really appreciate it.
It's good to hear. Yeah, so that's all I had about it. If there are any questions, we'd be happy to try.
An interesting question that again popped up, which I actually also thought of when you were talking about Redshift and BigQuery. Michael again is interested in knowing Redshift is not a managed service. Why did you think BigQuery was comparable to Redshift?
I guess we're just looking at, in that case, we needed a kind of a semi-structured, the ability to do these semi-structured queries on large quantities of data. Those were the two. So what we tried to do here was pick services on each platform that would satisfy the requirements for what we were trying to do, and those were the two that we thought were closest for what we needed there.
It sounds like it was more that your use case didn't really require you to distinguish between the manageability aspect of the two services.
Yeah, exactly. We definitely prefer managed services whenever we can use them.
Makes sense. Thank you. That was all the questions that came up in chat.
All right. Guys, thank you so much for taking the time. This was really interesting for me. Again, I think our backgrounds in test automation just made this a really interesting topic. It was really interesting for us to hear, both how you kind of designed your service, how you evaluated all the components that went into it, and how you made those decisions. Very happy to hear that we came out on top. So. Thanks again for taking the time to talk to us. Really appreciate it.
Sorry, there's one more. I'll interrupt.
All right, we got
one more
question.
Last question. Yes. What size compute did you provision for Redshift?
Oh, geez. That one, that was a long time ago. I'm afraid that I don't recall exactly what we were looking at on that one. I'm sorry, I don't have a better answer for that.
Sorry, Michael. I tried.
That was a while ago.
Yeah.
Understood. Folks on the line, folks in the chat. Also, if you have other questions that we're just not going to have time to get to today, you can always tweet us at GCP Online, and we'll be sure to get those answers for you. So great. I think with that, we'll wrap it up.
Yeah.
All right. Hey, James and Izzy, thank you so much. We really appreciate it. And yeah, again, once you guys decide on the multi-regional architecture, let's have you back on so we can talk about how you did that.
Yeah, let's do it.
Sounds good. Thank you.
Thanks so much.
All right. Thanks again, everyone on YouTube. Like, rate, subscribe. Is that what I'm supposed to say?
Yep.
I've got a budding career as a YouTuber. Priyanka, thank you so much for joining us. It's great to have you.
Thank you for having me.
Yeah, no, it's a pleasure. I know you'll be back. Looking forward to it. All right, folks, with that, we're signing off. If we don't see you before the holidays, have a great holiday break and a Happy New Year.